So problem 3 is asking about a convex mirror, which has an object at a distance larger than twice the magnitude of the focal length of the mirror. And it wants us to give our answer in terms of x and r for a, b, and c. So the first thing I did for this was draw some pictures at a few different points in relation to this convex mirror to see how the arrow's magnitude, or magnification rather, and position changed. So this first one is between f and 2f, and you're going to see in the next part the arrow will get smaller and move towards f. So that's what you see, and then that's at 2f, and then beyond 2f, once again, that arrow gets even smaller and moves towards f. So we could kind of really lightly answer these already just using these pictures, A, B, and C, but for now I will also show the math. So A, which is where will the image appear, so that's evaluating at S prime. We were given that x has to be bigger than r, and also that r equals 2f. So since it wants us to put everything in respect to r and x, we're going to plug in some values into our lens equation. So also notably, because it's a convex mirror, that focal length is going to be negative. So that's really important to not forget for your calculation to be accurate. And once you plug those in, I simply just simplified this expression down until we're going to see what I get in the next slide. Rx over negative 2x minus r equals s prime, with r being constant and x being bigger than r. So now to find the range of values that s prime will be, or the range of locations that that image is going to be located at, I evaluated the limit for the expression at r and infinity, because those are the only values that x can be. X is going to be between infinity and r. So when you evaluate at r, you get a value of negative 1/3 r. That's the location. And then when you evaluate at infinity, you get infinity over infinity, which, just in case that you can use L'Hopital's rule and differentiate the top and the bottom. And once you do that, you get a value of r over negative 2. So that means for the boundaries of x being between infinity and r, s prime will be larger than negative 1/2 r, but smaller than negative 1/3 r. And notably, negative 1/2 r is equivalent to negative f. So going back to these pictures really quick, you can see that that arrow is approaching that negative f value, the focal length on the right of the picture. So that seems to be true. Part B asks, will it be inverted? We can see from the picture that it won't be, but we also just know that since s prime will be negative, the negatives in the magnification equation will cancel out, giving us a non-inverted image. So it will be upright. C is asking, what will its magnification be? I did more limits here, but I'm sure there's a simpler way. We know that s prime can only be between those values, negative 1/2 r to negative 1/3 r, but s can be from r to infinity. So we're going to evaluate that magnification expression as s approaches r and s approaches infinity. So when we do it at r, we get that the minimum value, we get negative s prime over r. And then I went ahead and just plugged in the smallest value that s prime can be, which is negative 1/2 r, to get that minimum magnification, or rather max magnification, for this situation. So once we plug that in, we get negative 1/2 r over r, and that simplifies to just 1/2. Next, when we do it at infinity, we get negative s prime over infinity, which just equals 0. So that means our magnification is going to be between 0 and 1/2. So there are a few tricky things about this problem. Limits were the easiest way for me to solve it, but I'm sure there are ways you could solve it differently. I think that drawing the pictures is extremely helpful because it tells you if you're going in the right direction with your math. And it's also really good to be really careful about your signage throughout this problem because that can give you very different answers if you aren't careful. But that's pretty much it. Thank you for listening.